Yes, students. So let's start day 11, and it is actually a mixture of thermodynamics and kinetic theory of gases. Okay. All right. So let's start then. Yesterday we were talking about graphs, so we are continuing with that only. Okay. The simple questions which are very common. You can find them in all the question papers, and thermodynamics being one of the most important chapters. So I thought that okay, every graph possible we will take. Okay. Now let's see. This is PV graph here, and relation between T1 and T2 is asked from us. Simple it is, if we can analyze it what it is saying. So PV graph's area gives us what? Work done, we all know. Okay, but here these are isotherms, both are isothermal processes. This is total temperature constant. The isotherm, both. This is also. Okay, so what we know about this one? We know that yes, this is going to give us work done also. But at the same time, we know that there is a relation which is PV equal to nRT, that is ideal gas equation. And PV here represents what? Work. Work done. PV represents work done. That's equal to nRT. Now, in which process more work done? More work is done. In T1, which process more area is involved? In T1, the first process, or in this T2? The answer is in T1. More work is there in T1 as compared to T2. Okay, so we'll say that over here. PV is more in which process? Here. So where temperature will be more? Here. Because temperature is proportional to what? Work done only, right? So in which one work done is more? In the first process. So we can say T1 will be greater than T2. Okay, in this process it's like this. Let's move ahead and see what more graphs are there for us. Here it is. The TP graph. Okay, and in TP graph you can see this is the process. Okay, what is constant here? The temperature is constant. This is also isotherm. Okay, so process is indicating first temperature constant. Okay, then temperature is constant, fine, but pressure is increasing, right? Pressure is increasing. So pressure is increasing. Then temperature constant, pressure is increasing means volume has to decrease. So volume is decreasing. Okay. What we can comment about heat? Heat is being given or heat is being taken. What about internal energy? What's happening? The temperature is constant. Internal energy is not changing. Okay. The delta U is 0. Okay. Delta U is 0. Okay, fine. What about heat? What we can say about heat? Heat is given or heat is not given? Work is done or not done? So work is definitely done. Temperature is constant. Okay. Pressure is increasing. Volume is changing. Volume is decreasing. So volume is decreasing means compression is done. Okay. Pressure is increasing, volume is decreasing. So compression. Negative work done. Okay. Work done is negative. Work done is negative. So what about delta Q? Heat. Delta U 0. Work done is negative. So we know that delta Q equal to what? Delta U plus W only. No? And you are saying W is negative. So delta Q is also negative. Delta Q negative means heat is released. Okay. Heat is released, not added. Heat is released. Now they can ask you any question from this or this. Okay. That's TP graph for you. Then Previous was TP graph. This is PT graph. Okay. And this also same, like this is temperature is here now, and this is straight line. So again, this is isothermal. What is the difference? The same process. See, previous one was what? Pressure was increasing, temperature was constant. Here also, pressure is increasing, temperature is constant. So it's the same thing. Pressure increasing, volume decreasing, compression, work done negative, delta U 0 and delta Q is negative. That means Q is released. So same question. Okay. Same like last one. Same like last question. Okay, what we can do is we can make it going down. Then it can be a different question. Okay, otherwise it is the same question as the last one. So if suppose this arrow I change, I make a different arrow and make it down. Okay, then what do you say? Okay, now this is not a last question. So we can say that in this one pressure is going down. Temperature is constant, yes, pressure is going down. So pressure is going down. Volume has to go up. Okay, pressure going down, volume is going up. Okay, fine. Then what else we can say about this one? Delta U 0, it's a constant temperature process. Volume is increasing means work done is positive. And if work done is positive, that means Q is added. Q is also positive. That means heat is added. Okay, right. Fine, let's move ahead. Okay, this is VT graph now. In VT graph, and this curve is starting from the same line as if it's starting from origin. Okay, it's not starting from origin, starting from some other value, but it's like this. Okay, so when it says that it's starting from origin, that means it says P is constant. It is already mentioned here. P is constant. Okay, fine. If it starts from origin or it looks like it's starting from origin, we can say P is constant. Now, what is happening in this? Temperature is also increasing, volume is also increasing. Okay, temperature and volume both are increasing. Temperature is increasing, volume is also increasing. Okay, fine. And its slope? Slope represents what? Slope represents dV by dt. Change in volume to change in temperature relation, or you can simply say it's V by T. Okay, slope is V by T in this case. Okay, which represents P is constant, or V is directly proportional to T here. Okay, V is directly proportional to T. Slope is constant. All right, this was the basic thing. Now the questions will be on this VT graph. Let's see what these are. Okay. So this VT graph, we are asked that what is the relation between P1 and P2, and here also our graphs are actually like this. Okay, one more we will make something like this. Okay, so both actually are starting from origin or look like starting from origin. Okay, so in both the cases, what I can say, pressure is constant. So this pressure throughout is constant. This pressure throughout is constant. Right, now I have to tell you about, or rather we have to find about that whether P1 is greater or P2 is greater. So how to find that? As I told you, this is V directly proportional to T. These are the graph. That means V by T is constant. Slope is constant here. Slope is constant. So okay. And V by T represents what? Pressure. V by T represents pressure. So what you will do here, V by T means this slope and this slope. Okay, this is second one, let's say theta 2, this is theta 1. So we can see clearly tan theta 2 is more than tan theta 1. Okay, tan theta 2 represents what? Tan theta 2 represents V2 by T2 and this represents V1 by T1 and V2 by T2 is what? P2 and V1 by T1 is what? P1. Okay, so what you can say? P2 is greater than P1 in this case. There's no doubt about that. Okay, so slope gives you the value of pressure. How we are getting? We know now an ideal gas equation. Okay, so what is V by T here? Oh, I did it wrong. V by T is actually 1 by P. Thank God we checked it. Otherwise, we would have given the wrong answer. V by T is equal to 1 by P. So, backside also we have to change. No, this is fine. Here I didn't say anything. V by T equal to constant. I said fine. That is okay. Okay. But here V by T is actually 1 by P. This one answer will go different. Okay. So, V by T is proportional to 1 by P. Okay. So, V by T is proportional to 1 by P means 1 by P2 is greater than 1 by P1. So, answer is what? P1 greater than P2. Okay. Answer is P1 greater than P2. So, this is how we are going to see that what it represents. Okay. From ideal gas equation. V by T is actually 1 by P. Okay. So, this is how the answer is going to come. Alright. Then this is PT graph. One more time PT graph. PT graph we did it, right? Already PT graph we did. I am correct. Yeah, we have done PT graph. Yeah. So we'll make it VT graph. Okay. This is VT graph. Okay. Now what the process is? So in VT graph, what you can see is this is a constant volume. Okay. The first thing is the constant volume. Right. What is the second thing? Temperature is increasing. Right. So temperature is increasing. Temperature going up. Volume is constant, temperature is going up. What we can say then? If volume is constant, okay, if volume is constant, can we say that P is directly proportional to T? Obviously, you can see that PV equal to nRT. This is constant. Okay, so P is directly proportional to T. Right. So if temperature is increasing, its pressure also increases. And if temperature increases, it means delta U is positive. Temperature increases means internal energy is going to increase. Or let's write U. Don't write delta U. Okay. So internal energy is increasing. What about work done? Work done is 0. Why? It's a constant volume. So work done 0. But change in internal energy is increasing. If change in internal energy or rather final internal energy is increasing, means you have given the heat. Q is added. Delta Q is positive. Heat is added. Okay, so this is how we can conclude this graph also. Okay, then okay, PD graph, and it looks like it's starting from origin. Looks like it's starting from origin. Okay, fine. So if it starts from origin, now in this one we will not make mistake, right? Okay, so it's starting from origin means what? Volume is constant. P is directly proportional to T, right? Okay, starting from origin means P is directly proportional to temperature. Volume is constant. volume is constant. Now its slope represents what? Slope of this. The slope is constant, we know, but what is slope? Slope is constant. Slope is P by T. P by T is constant. Okay, so P by T means what? We know that PV is equal to nRT. So P by T is equal to nR by V. That means P by T is inversely proportional to volume. P by T is inversely proportional to volume. Okay, let's see in the next question we have that thing only or different thing. Yeah, similar question. Okay, so which one is greater? What we can comment about V1 and V2? Compare V1 and V2. So it's clear now. In this one, whose slope is more? 2. This we can see. Okay, this is theta 2, this is theta 1. So theta 2 is clearly greater than theta 1. So we can write 10 theta 2 is greater than 10 theta 1. The first thing. Now 10 theta 2 means what? 10 theta 2 means V2 by T2. And this is V1 by T1. And what we saw already in this case, we saw that ideal gas equation says us PV equal to nRT. Okay, and in this one V is constant. Correct only, no? Okay, this V2 is actually P2 and V1 is actually P1. This is P2 by T2 and this is P1 by T. Okay, right. So in this one, what is there? Volume is constant. So we know that P by T is actually 1 by V. Okay, P by T represents 1 by V. Okay, fine. So P2 by T2 means what? 1 by V2 is greater than 1 by V1. What is the answer? V1 is greater than V2. V1 is greater than V2. If suppose the opposite process we are making, TP graph we are making. In TP graph, the same thing. Then what will happen? Then the answer will change. It will become V2 greater than V1. Shall we do that? Okay, here only I will make. Okay, see. And here is like this. Then let's make it from origin directly. This is one more and one more. Okay, and the graph is what? TP graph. And this is V1 and this is V2. Okay, now you can see here this is theta 1 and this is theta 2. Okay, 10 theta 2 is greater than 10 theta 1 here also. But what is 10 theta 2 and what is 10 theta 1 here? 10 theta 2 represents T by P. That means T2 by P2 is greater than T1 by P1. Now what is T by P? T by P means inverse of this. That means it represents V. So here will come V2 greater than V1. So be careful whether PT graph is there or TP graph is there. Okay? Right? Okay then. What is this? Again PT graph. VT graph it will be, okay. This will be VT graph. Right. So this is VT graph. What it says you? Volume is constant. Okay. Volume is constant. Temperature going up. Now when volume constant, temperature goes up means pressure also goes up. It has to go up because when volume is constant, pressure is directly proportional to temperature. Okay, temperature going up, pressure going up. What we can say? U is going up, internal energy is going up, work is 0 because volume is constant. So that means Q is also added. Okay, Q is added. Okay, so like this you have to be able to conclude take out the information from the graph. Okay. Okay. Now what we have convergence. Convergence means you have to convert this graph in VT graph and PT graph. What is this? This is a PV graph here. This is the graph. The cyclic process, you can say. Okay, this is a cyclic process. And we have to convert this PV graph into VT graph and PT graph. Okay, so first here this is shown that this is isothermal process. This is AB, let's say, BC, this is D. So four processes are there: AB, BC, CD and DA. Okay, AB is isothermal. So let's talk about AB first. Process AB. Okay, one by one we will try to conclude and then we will make those graphs. Okay, so in PV graph what is happening? First thing is pressure is decreasing. Okay, pressure is going down. Pressure is going down. What about volume? Volume is increasing. Temperature is constant, obviously. It's isothermal. Temperature constant. Okay, BC. What we can say about BC here? BC is pressure constant. Okay, volume increasing. Pressure constant. Volume increasing. What about temperature? Pressure is constant, volume increasing means temperature also increasing. Okay, what about CD? Process CD says volume is constant, V constant. Okay, then pressure increasing means temperature also has to increase. Okay, then DA, final process. Now in DA what's happening? In DA volume is decreasing, it's a pressure constant. Okay, first is pressure is constant here, the P constant. Volume decreasing. Volume is decreasing means temperature also decreases. Okay, this much we can conclude from these processes. Now we have to project it on first, let's say VT graph. Okay, so in VT graph, first this one I am going to put this AB process we are going to project. So what it is? T constant first. Okay, so T is constant. Okay, T is constant means something like this, but volume is increasing. So see, I am making it. This is for me AB. Temperature constant, volume has increased. Then BC, pressure is constant, volume increases, temperature increases. So first thing is pressure constant. It's a VT graph and you have pressure constant. So how it will be looking like? It is starting from origin, remember. Okay, so let's make it little smaller. Okay, so AB is here. Okay, now BC I have to make it like this. So it should look like it is starting from where? From origin. Okay, so it's like this. Starting from origin means I'll just connect these two. Okay, and how is the process? Process is this. Okay, this is your BC. Right? So what it shows? Pressure constant, volume is also increasing, temperature is also increasing. Then CD. CD is volume constant, pressure increases, temperature also increases. Volume constant. So okay, volume constant, we'll make it straight line only will come. So here it is. Okay, volume is constant, temperature is increasing. Okay, then final. It says P constant again, but volume is decreasing, temperature also decreasing. Volume is decreasing, temperature also decreasing. Okay, fine. But it's a cyclic process also. That means you have to return back to the same place. So, okay, our starting place is this. From here, we'll return back. Okay, fine. So, let's come back. Oh, okay. And this will look like it's coming from the origin. Something like this. Okay. So, how are the arrows? Arrows we have already done. This is A to B, B to C, C to D, and D to A. Okay. So, conversion of this into VT graph. PT graph is left. Again, let's go to PT graph. AB process. Temperature is constant, pressure is decreasing. Temperature constant, pressure decreasing. It's like this. Okay, that's AB for you. A and this is B. Okay, then T constant, temperature increases. T constant, temperature increases. Okay, T constant means like this. Temperature increases means like this only. That's BC. Okay, then next one, V constant, pressure goes up, temperature goes up. Okay, fine. So how will that be? That will be like this. Okay, what we can do is, can we bring this one down? Let me check. Okay, this graph will bring down, but this is bringing the logo also down, huh? Okay, and select it again. Okay, now also. Okay, leave it. Unnecessary that is. We'll make it there only. Okay. So now what? What is the final one? Rather, third one. V constant, pressure increases, temperature increases. Okay, fine. So V constant. A V constant means pressure directly proportional to temperature. That means it should look like it's coming from this. So that's why the problem was there. Okay. Because it was not looking that it is coming from there. So shall I make it slightly upwards or what? Okay, fine. So from here we'll make it like this. Okay, pressure is also increasing, temperature is also increasing, and it should look like it's coming from here. Though in this one I am not able to, but okay. Then what is final? T constant and temperature is decreasing, but first is P constant, and it's a cyclic process. So it has to come back to its initial point. So here it is. Okay, so this is the process. A to B, B to C, C to D, and D to A. This is PT graph, this is VT graph. So you should be able to make this. Okay, here we have made one by one all the process, but in the exam, you know that options will be given. So any two processes, if we are going to make it correct, you will be able to identify the option. Okay. One more question we will do similarly. Okay, here it is. So same now, in this one also, we have to make PT graph is given. Corresponding graphs we have to make. What will be corresponding graph? PV graph will be there. What is written? VT and PT. PT is already given, so VT is not there. PV it will be. So this will be PV graph. Okay. And in this one, how the process is? It's like A, B, C, D and then A. Okay, like this. So we have to make what? VT graph and PV graph. Okay, fine. So let's make two graphs here. Small graphs I am making this time so that we can make it within less space only. So here are two graphs. VT. Okay, let's check. In first AB process, what is happening? Okay, in AB process, I can see that temperature is constant first. So this is isothermal process, right? T is constant. Okay, pressure is coming down. Now, if pressure is coming down means volume has to increase, right? Okay, BC. BC is constant pressure. What about temperature? Temperature is going up. Temperature is going up means volume also, because P is constant. Okay, P is constant, so volume will be proportional to temperature. Then CD, this is a PT curve, and you can see that it's coming from infinity, or rather not infinity, from origin. So that means P is directly proportional to temperature. P directly proportional to temperature means volume constant. Okay, so CD, volume constant. Okay, pressure is also increasing, temperature is also increasing. Pressure proportional to temperature. Then what is the process? dA, constant pressure. Okay, dA is constant pressure. Constant pressure, temperature is going down. So if temperature is going down, that means volume also has to go down. Okay, so this is what we have now. Now we have to make a VT graph out of this. So AB process is what? T constant. Volume is going up, pressure is going down. So first temperature is constant. Okay, and volume is going up. So temperature constant and volume is going up. It's like this. Temperature constant, volume is going up. Okay, this is AB. So AB here. Then second process VC. It says pressure constant, okay. T and V both are increasing. Pressure constant. That means it should look like it's coming from origin, just like this one. Okay. So just coming from origin means we make it like this. Okay, something like this. So this is your VC. Then volume is constant. First P is constant, now volume is constant. So volume is constant means it will be a straight line. And temperature has to increase, right? Volume is constant and temperature has to increase. Which one? Which process? CD. Yes, temperature is increasing. So volume constant, temperature increases. So it's like this. Okay. This is our CD. Now then what is dA? dA is pressure constant. Now pressure constant, it's a VT graph. That means again it should look like it's coming from origin. But it's a cyclic process. So D has to be joined with A. Okay. We'll join D with A. So yes, it looks like it's coming from origin only. That's perfect. Okay. So AB, BC, CD, DA. This is your VT graph. Okay. Now what PV graph also we have to make. Okay, let's see. How's PV graph? Okay. PV. Now what is first? First is isothermal. T is constant. P is going down. V is increasing. Isothermal means, okay. So like this. This is AB. V is increasing, pressure is decreasing. Isothermal process. Okay, fine. Now BC is P constant. P is constant, so P constant we can make, and V is increasing. Okay, okay. P is constant and volume is increasing. So P is constant, volume is increasing like this. Straight line. Okay, then what? CD, volume constant, pressure is increasing. Okay, volume constant, pressure is increasing. That is which process? CD. Okay, so it will be like this. Okay, like this. Then what? Finally, dA is what? Constant pressure. Okay, then we have to connect it directly with volume decreasing. And that was easy. Okay, that's it. So AB, this is BC, this is CD, and this is DA. Okay, isn't it similar to the last question we did? Yes. Oh my God. That means same graphs we have got. Check. VT graph here and VT graph here, where it is. See? It's similar. Check. Okay. Similar graph. And this PT graph and that PT graph will be similar. There. Yeah. Okay. Right. So same questions we did, but yes, we did the effort in solving it. Okay. All right. Let's see then what next. Okay. There's a PV graph given and two processes are given. One is like this one, and another one is like this one. Starting point is A and finishing point is B. Okay, and U1, U2, that is change in internal and not change in internal energy. Yeah, change in internal energy only. U1 and U2 are change in internal energy given. In which process more heat is involved? Okay, that's a different process because here options are given for internal energy only. So first let's solve this one, then we'll come on this one. This is a different question, this is a different question. Okay, what we can say over here? U1 and U2. Now U1 and U2 represent change in internal energy. If A and B are same, this process also for AB, this process also AB. The change in internal energy doesn't depend on how you reach. It depends only on initial and final position. So here also initial position is same, here also initial position is same. So our answer will be what? U1 equal to U2. Okay. Now let's come on to this. In which process more heat is involved? Now what we can say, if suppose this upper one I can say, then I know that work done is more in that process only. Because this entire area will come under work done for the upper process. So W1, if I say here work done is W1 and here work done is W2, then it's very clear that W1 is more than W2. Change in internal energy is same, okay, but W1 is greater than W2. So then Q is what? U plus W. Okay, so we can clearly say that with Q1, which is actually U1 plus W1, and Q2, which is U2 plus W2, with U1 and U2 are equal. So since W1 is greater than W2, we can say Q1 is greater than Q2. Q1 is greater than Q2. Right? Okay. Okay, what this is now? PV graph is given and this is how the process is. In given process, how work is changing with time. With time. So one change in the question. That's okay, fine. How work is changing with time. So work is, that means as the time is passing, how work is changing. Continuously increasing, continuously decreasing, first increases then decreases, first decreases then increases. Okay, so what we can do? Now, work done means is area under PV curve. With time, what is happening? So, with time, what is happening? Let's say we are starting from here. Okay, we started from here. And with time, is our position changing? Obviously. After 1 second, let's say you are here. After second you are here. After third second, you are here. After fourth second, you are here. After fifth second, you are here. So, in first second, how much work will be done? We will say this much. In 2 seconds, how much work is done? We will say this much. In 3 seconds, how much work is done now? It's this much. Fourth second, how much is done? This much. So, work done is increasing with time or decreasing with time? Increasing. Because in 1 second, only this much area was there. In 2 seconds, this also added. 3 seconds, this is also added. Fourth second, this is also added. So, it's increasing continuously. Fifth second, this is also added. Sixth second, this will be added. Seventh second, this will be added. Eighth second, this will be added. So, our answer is okay. Work done is continuously increasing with time. Okay. Okay. Now, what this is? This is also cyclic process we have. Okay. So, how we can move in this one? This is A, B, and C. And this is A, B, and C. Okay. One more thing I will make in this one. I will connect this. Why? Because he is asking about AC. So he says this is the process. There are in fact two processes, A to B, B to C, and there is A to D and D to C, through which you can reach from A to C. Question is asking us delta U AC, and what is given? He said that during AB process, how much heat is added? 600 joule, and during DC process, 200 joule is added. So what is change in internal energy? Okay, fine. Delta UAC we have to find. So can we do something like this, like delta UAC will be delta UAB plus delta UBC. Okay, because delta UAB means what? It is actually UB minus UA, and delta UBC means what? UC minus UB. The UB gets cancelled. It is UC minus UA. Absolutely, that is only delta UAC. Okay, so you can add this one with this one. So here if delta U we can get, and here delta U we can get, then we can get delta UAC very easily. Okay, fine. So what is this process? This process is constant volume process. Okay, in constant volume process, work done is zero. So I am talking about AB process, right? AB, process AB. Okay, what is that? Constant volume. So work done in AB is zero. Okay, and it is given QAB 600 joule. So QAB 600 means delta UAB also 600, because first law of thermodynamics says what? QAB equal to delta UAB plus WAB, correct? QAB to delta UAB plus WAB. This is 600. So then delta UAB also 600, because this is 0. So we got delta UAB here. Now delta UBC we have to find. Okay. So in that process also, how much heat is given we know. But this is what process? This is constant pressure process. And in this one work is done. How much work is done? Area. Area under PV curve. So that means which area? This area. This entirely. Entirely means this is rectangle. So work done in BC we can find. Work done in BC is how much? This is 8. So 8 into 10 to the power 4. And this is 3. So 3 into 10 to the power minus 3. This is in meter cube, this is in Pascal. So absolutely we don't have to worry about the units as such. It will come in Joule on. Okay. So how much it is that? 240, I think. This is 240 Joule. Okay. So let's talk about process BC now. So process BC. Okay. So QBC delta UBC plus WBC. So this is 200 given. This we are calculating, and this you got already here, that is 240. Okay. So delta UBC is coming minus 40. Okay. So delta UAB also I got, that is 600 joule. Delta UBC I got minus 40 joule. I am going to put it over here. So what we are getting? 600, and this is minus 40. Our answer is what? 560. Delta U AC is 560. Below one information may be given. So similar way that also we can do, but delta U AC will come out somehow and it will be coming same only. So we are not bothered as such. What will be the given value for that? Okay. Let's see what next. Okay. So next is we should be talking about different processes now. Different processes we already have done, but formula we never discussed, right? Formulas for work done in different processes. Work done in different processes. Formulas are what? Okay, because we didn't do any question on formula till now. Okay, so first one, isochoric. When we talk about isochoric process, we already know that work done is 0 in this because volume is constant. Work done is 0, so delta Q is equal to delta U. We know this, right? This is isochoric process. Then we'll go for isobaric process. What happens in isobaric? Let's see. Here we'll do isobaric process, pressure is constant. So work done is P delta V. Okay, pressure is constant, so it's P delta V, very simple. In another form, P delta V is also equal to NR delta T. Okay, P delta V or NR delta T. So work done is calculated like this. Delta U is NCV delta T always. Here also delta U is NCV delta T. So in this case, delta Q is also NCV delta T. Okay. Then here delta Q will be what? Delta Q is delta U plus W. So in this one, this is NCV delta T, this is NR delta T. So this will come as NCP delta T. That's delta Q. So this is about isobaric process. Okay, then what we have? We have isothermal process. Isothermal. And isothermal, what is the formula for work done? Formula is, but first of all, T is constant. Delta U 0. Then work done formula is nRT ln V2 by V1 or nRT ln P1 by P2. nRT ln P1 by P2. Now In this one, negative work done is there or positive work done is there. Normally people will get confused. So remember always, it's very simple. If volume is decreasing, it's a compression. So work is done on the system. So work done will come negative. Okay. If V2 is less than V1, that's what I am saying. If compression. Or if P1 is greater than P2, that means pressure is increasing. Pressure when it increases, when you compress, it will come negative. So no need to worry about that. Okay. So that way we can easily find out whether compression is there or expansion. Expansion means positive work done, compression means negative work done. So W equal to nRT log of V2 by V1 or nRT log of P1 by P2. Okay. So in this one, temperature is constant. Fine. Delta U is 0. Okay. Now in this one, what is its specific heat? Now specific heat actually is what? Delta Q by N delta T. Now you said that delta T is 0 and this T is constant. So C value in this case is infinite. Specific heat of isothermal process is infinite. Okay. Then what process is left? Adiabatic. In adiabatic, what is there? Okay. One more thing here. Isothermal process means PV constant. PV is constant. Or PV equal to constant. Okay. Adiabatic process, PV to the power gamma is constant. Delta Q 0. Delta Q is 0 there. No heat is transferred between system and surrounding in adiabatic process. So if delta Q is 0, we can write delta U plus W is 0. That means W equal to minus delta U. That means W equal to minus N CV delta T. That is minus N CV T final minus T initial. Write CV value also. Minus N R by gamma minus 1 T final minus T initial. Minus NR gamma minus 1 T final minus T initial. See how all this minus and all these things are coming. Same way we have to keep. And in this one also very simple. We can find out whether compression is happening or expansion is happening. Expansion means positive work done, compression means negative work done. Very, very simple concept. Okay. Okay, this is in terms of pressure, temperature only. Can't we have in terms of pressure and volume the same formula? We can have, why not? We can have. W equal to minus NR by gamma minus 1 here at the moment. So what we can do? 1 by or minus you take here only. I am not taking it inside. Now what it will become? NR T final minus NR T initial. Now NR T final, what I can write? P final V final minus P initial V initial. So same one we can write this in this way. So W equal to P final V final minus P initial V initial by gamma minus 1 and here is minus. Now how this NR by gamma minus 1 is coming, CV's value? Okay, that also we will see. So what we know, CP by CV is gamma and CP minus CV equal to R. So CP value I can write as gamma CV minus CV equal to R. Take CV common, gamma minus 1 equal to R. So CV value R by gamma minus 1. Okay, so CV value R by gamma minus 1. So you have to remember this formula. This is the formula, direct formula. If the direct formula question is coming, these are the formulas we should be using. Okay. All right, let's move ahead. Just a minute. Students, are you attending continuously? No? Students?
Yes, sir.
In between, I think some network problem was there, right?
Yes, sir.
Okay, so but you attended this, no? What I explained?
Yes, sir.
Okay.
Yes, sir.
Okay, okay, good. Good. All right. Anything is, I think some portion in the on the board also slightly is going out of the screen. You are not able to see. Just a moment. I'll just try and yeah, I'll just try and bring it back to the focus. All right. Okay. So these are the formulas for various processes, isothermal, adiabatic, and all that. Okay. Let's solve few questions on this. See how bigger is this thermodynamics. But from thermodynamics itself, you expect 3 to 4 questions. So that is why we have to take this all the things so that you don't miss anything. Okay. So suppose now I am making one question. It says that number of moles are 6 moles for a monoatomic gas, and temperature, and let's say initial temperature is 300 Kelvin, and final temperature you'll make as 400 Kelvin. Okay, 6 moles monoatomic gas, initial temperature 300, final temperature 400, and work done. Find work done in given adiabatic process. Given adiabatic process. This is our question. Okay. All right. So that means we are going to use the formula. What is our formula? Formula says it is NR by gamma minus 1. Here is minus TF minus TI. Okay. Now it says that temperature is increasing. With the temperature is increasing, are we able to find out that whether there is a compression or expansion? Answer is yes. Because this is adiabatic process, heat is not given. Heat is not given. So then how temperature is increasing? You have done compression. When you do compression, when you are going to work on it, then only temperature will increase. Otherwise, there is no way. So compression is being done, that means our work done is on the system. It will come negative. Okay, simple. That's how you have to find. Okay. So number of moles 6, and R I am writing as R only. Okay, I am not writing it as the value of gas constant. Okay, let it be R only. 6R. Gamma. Gamma for monoatomic gas means 5 by 3. So 5 by 3 minus 1. This is 400 Kelvin, and this is 300 Kelvin. Answer is negative. You can see that. Okay. So minus 6R. 5 by 3 minus 1 means 2 by 3, and this is 100. So this will go up. This also I can cancel 3. So this will go minus 9R into 100 joule. Okay, so minus 900 R joule. That is the work done in this process, which is given to us for adiabatic. Okay, right. So this way we can find. If suppose that opposite thing I would have given you, this is 400 and this is 300. So you would have said that okay, temperature is going down. The temperature is going. How temperature goes down? When you are not taking any heat out, and definitely expansion is being done. So this way you have to think. Or other way, how they can ask you directly, they will give you pressure and volume. So if they are giving pressure and volume, from there it's very easy for us to find out whether it's increasing or rather volume is increasing or decreasing. Okay. One question we will do for isothermal also. Let's check there also positive and negative. Okay. So, an isothermal we will do. The question says, let's say N is equal to 2 moles for a diatomic gas. Okay. All right. Initial pressure, let's say is 8 Pascal, and final pressure is 16 Pascal. Find work done. Okay. Now what's happening here? You can see that pressure is increasing. Pressure is increasing means what we are doing? Compression. Compression only we are doing. Okay. Pressure increases means volume decreases. Temperature is constant. So if compression is being done, that means work done will be negative. Okay. But one more thing is there. Okay. First I am doing. Find work done by gas. Okay. So here is work done is, what is the formula? nRT ln P2 by P1 or P1 by P2? P1 by P2. Okay. So N is given 2, R is as it is. Temperature also I have to give. So temperature is, let's say, 100 Kelvin. So 100 Kelvin. Then ln P1. P1 is 8 by 16. So 8 by 16, once you write, it will come negative only. So 200 R, okay, log of 1 by 2. So this is negative answer. Then, if suppose this would have asked find work done by surroundings, then so surrounding when it is doing, okay, then this answer would have become positive. By the gas it is negative because surrounding is doing the work. So surrounding is compressing only. So surrounding does positive work. Gas is doing negative work. So be little careful. If we ask what is work done by surrounding, same thing will come as positive. Here it's coming negative. So what you have to do? Calculate what is work done by gas. There is no problem. If it's compression, negative. Okay. But if the question is asking surrounding, make it positive and give it. Okay. Just be careful for the words. So this is it as far as thermodynamics is concerned. Okay. Now in the same one, we are starting KTG because there is not much of the difference in the concept and other things except one formula of pressure. Nothing much is there. Okay. Nothing much different is there. The kinetic theory of gases. So in kinetic theory of gases only gives us idea about ideal gas equations. So ideal gas equations from where we get? We get from basic laws. What basic laws? We all know. Boyle's law. Okay. Boyle's law, which says that temperature is constant. Temperature is constant. Then what? Pressure is inversely proportional to volume. Or PV is constant. Okay. Second law, Charles. Charles' law says pressure is constant. Then volume is directly proportional to temperature. Okay, or V by T is constant. Then Gay-Lussac law, what it says? Galois law says volume is constant. Then pressure is directly proportional to temperature, or P by T is constant. And then last one, Avogadro's law. Avogadro's law says what then? It says that if pressure and temperature kept constant, if pressure and temperature are constant, then volume occupied by gas is directly proportional to number of moles of the gas. Volume is directly proportional to number of molecules, a number of moles. Number of moles of gas. Okay, so these are the four basic laws, and when we use them all, we get ideal gas equation. Ideal gas equation, PV equal to nRT. PV equal to nRT. Okay. This N is number of moles and this is equal to mass of gas by molecular mass of the gas. Okay, mass of gas by molecular mass of the gas. That means I can write this as PV equal to M by M into R into T. Okay, further P equal to M by V into RT by M. So M by V we can write in terms of density. So P equal to rho RT by M. So this is also important. This is important and this anyhow important. There is no doubt about that. Okay. So when we are talking about number of moles, this ideal gas equation we represent or we use in these three forms. But if suppose we are going to use it in number of molecules, then what we do? Then what this is going to become? Now, same equation, if we are going to use for number of molecules, it becomes NKT. PV equal to NKT. Now, what this K is? K is Boltzmann constant. Boltzmann constant. And K is equal to what actually? K is equal to R by Na. K is equal to R by Na. R is what? Universal gas constant. R is universal gas constant. And its value also you know, 8.314 joule per mole per Kelvin. Okay, 8.314 joule per mole per Kelvin, right? Then K, okay, K is Boltzmann constant. Now its value is what? 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, so when we are talking about molecules, this is how the equation changes. Okay, fine. So we have to remember that if in terms of molecules, if it is asked, we'll use it. K value anyhow we have, and this N represents what? Number of molecules. Number of molecules. Okay, clear? Okay, right. This is about ideal gas equation. So can we do some questions on this also related to graph? Yeah, why not? See that graph questions are here also. So how the question is, see, you make a graph. It has become very hot. Already 8 o'clock itself, now it's 7:30 itself, it's becoming very hot. And the process is like this. Right. What graph it is? VT graph. Okay, this is VT graph. Now what we can say about this process? Okay, what this process represent? Okay, pressure increasing, temperature is increasing, we know, volume is increasing, we know. Is pressure increasing, pressure decreasing? What's happening over here? That we have to check. Okay, what to do? See, what I'll do is, I'll make 3 lines here which are starting from origin here. Okay, and I'll cut at different points. Okay, so let's make one. Okay, like this. This is one. One more we'll make. Like this. This is 2. One more we make. 2 are enough, but let's make third also. This is third one. Okay. Right. Now these are all starting from origin. Okay. And this is VT graph. So I can say that these are all representing constant pressure process, right or not? This is constant pressure, this is constant pressure, this is constant pressure. Okay. Now see their slopes. This is theta 3, this is theta 2, and this is theta 1. And it's clear that theta 1 is greater than theta 2 is greater than theta 3. Theta 1 is greater than theta 2 is greater than theta 3. Now theta 1 means what? V1 by T1 greater than V2 by T2 greater than V3 by T3. Correct. Now V by T represents what? PV equal to nRT, you know. So V by T is actually representing nR by P. That means V by T is inversely proportional to V by T is inversely proportional to P. Okay. Okay. V by T is inversely proportional. So that means 1 by P1 greater than 1 by P2 greater than 1 by P3. So what's the answer? What we can say? We can say P3 is greater than P2 is greater than P1. P1 is the least. As you are going here up, pressure is continuously increasing. Okay, this is what this graph is representing. Right? Okay, few more graphs we can make. VT, okay, few more VT graphs. Okay, so this is also VT graph. Okay, this is one, and another one we'll make. Oh, not like this. what's happening. Something went wrong. Okay. So two processes, two graphs I have made. Okay. And suppose here I am saying its mass is m1 and its mass is m2. Okay. Mass is m1 and m2. What we can say about m1 and m2 here? Okay. Relation between m1 and m2. Okay. BD graph, it's starting from origin. So pressure is constant. Okay, pressure is constant first. We can say that. Now from ideal gas equation we know PV equal to nRT. So P is anyhow constant. Forget about that. Leave it. N and R R is also constant. Leave it. So V by T is actually proportional to N. And if number of moles are more, that means mass also will be more. So V by T is proportional to N. So this is theta 2, and this is theta 1. So tan theta 1 is greater than tan theta 2, means V1 by T1 is greater than V2 by T2. Now it says it's directly proportional. So that means N1 is greater than N2. That means M1 is greater than M2. Okay. So that's how we can find the relation between M1 and M2 here. Right. Okay. One more question. But this time I'll give you PT graph. Okay. This is PT graph for you. PT graph. Okay. This is PT graph now. And the graph is like this. Similar to one we did right now, no? In VT graph, same way it is. Now in this one, you have to tell me about volume. What the process is, first of all. Okay? Write about process. Now you can clearly see in this one, pressure is also increasing, temperature is also increasing. But is it constant volume? Say no, because this is not starting from the origin. If it was starting from origin, we would have said that it's constant volume, but it's not here. So that means volume is changing. That only we have to find how volume is changing here. Okay, so how we did the previous question, exactly same thing I'll do over here. Okay, what is that? 3 lines I'll make starting from origin, like this. This is one, then this is second one, what happened? Second, same with third. Okay, 1, 2, 3. Okay, and you can see that this theta 3 is less than theta 1. And what is theta 3 or tan theta 3? Tan theta 3 is less than tan theta 1. That means P3 by T3 is less than P1 by T1. Okay, now what it represents? Okay, PV equal to nRT. Number of moles constant, R is constant. Okay, and what we have done here, we have taken it from origin. Correct or not? We have taken it from origin, remember. So here is P by T. P by T is representing what? 1 by V. So here you are writing P3 by T3. So P3 by T3 we can write as 1 by V3. So 1 by V3 less than 1 by V1. What will come then? Says V1 is less than V3. So we can say V1 is less than V2 is less than V3, or V3 is greater than V2 is greater than V1. Okay, same way like the first question we solved, same way it is, exactly same way. Okay, alright, let's do few more. At least graph thing should be over. So question, one more question. Okay, PV graph we'll have this time. Here it is, PV graph. No, not this one. This is P, this is P. And in this PV, graph is like this. Okay. Graph is like this. Now what we have to comment in that one? We have to comment about temperature. Okay. How temperature is changing in this process. How temperature is changing in the process. Now what to do? Like the previous case only. Now in the previous case what we did? We were having PT graph. Okay. So we made 3 lines which were showing you constant volume. Okay, because it's starting from origin, so we made constant volume. So here in this case, PV graph is given, and in PV graph, what we used to take as constant temperature, no? Isothermal process, what we do? Make PV graph. So here also, what I am going to do is I am going to make isotherms. 3 isotherms I am going to make. 3 isotherms when I will be making, those isotherms must be cutting this one. Okay, this process. See how I am making. So first one, let's say with white color only. Okay, first is like this. Like this. Okay. The second one, okay, that's second. And third one, something like this. All are isotherms. Okay. So this is representing T3, this is representing T2, this is representing T1. Okay. Now what we can say about them? Now suppose that the same PV graph I make here and I ask you same thing. Like it's here. This is PV graph. Little while ago we have done it. Okay, this is one isotherm, this is another isotherm. This is T1, this is T2. Now I asked you whose temperature is more. Then we said that whose area is more, because PV represents area and PV equal to nRT. Remember that. So we said that its area is more because pressure involvement is more in that. Okay. The pressure is more, no, as compared to this one. So its area is more as compared to its area. So T2 is greater than T1. This was our answer. Little while ago we did it. Now here you see. Whose temperature is more with the same logic? It's a T3 greater than T2 greater than T1. Okay, so as you are moving from here to here, suppose this is A, this is B, and this is C. So when you move from A to B, temperature is increasing. When you move from B to C, temperature is decreasing. Because this entire curve means temperature T3, this entire is temperature T2, this entire is temperature T1. So first you increase from T1 to T2 to T3, then you decrease from T3 to T2 to T1. Okay, so in this process, first temperature increases and then temperature goes down. Okay, so this is a PV graph for a straight line which indicates this. Okay, One more we do, last question for today. And this week, Sunday, we have a class, remember, otherwise it will become very difficult. Okay? Sunday evening, we will definitely have a class. Okay, so one more graph. The graph is like this. Isotherm. Okay, this is PV. Suppose this is M1 and M2. Now, what do you say? What is the relation between M1 and M2? Find relation between M1 and M2. Find relation between M1 and M2. What we can say? Again, this is related to number of moles. Okay, PV equal to nRT we know. Okay, one more thing. The temperatures are constant. Both are having same temperature. Okay. So what we can say in this one? This one, this, it is having more area. This area is more. So I can say P1 V1 is greater than P2 V2. P1 V1 is greater than P2 V2. Now P1 V1 means what? nRT. Temperature is anyhow constant, R is also constant. So PV is directly proportional to N because R is constant, T is constant. T is same. Okay, so that means N1 is greater than N2. That means M1 is greater than. Okay, M1 is greater than M2. Okay, students, so that's all. Get the QR code, scan it. Wait a second, it's generating the QR code. It's taking time. Yeah. Okay, so scan it so that all the notes are reaching you. Okay. Okay, students, then that's all for today. And keep writing the practice test. See, crash course is very difficult. Actually, I am finding it very difficult because lot of work I have to do so that I can give you all the things. Nothing in the chapter is left. So my effort is at least 6.5 hours daily. I have to work for you. First of all, taking out the content that I have to discuss with you because I have to finish it as early as possible, and then again practice tests I have to make. It takes 6.5 hours. So please utilize it fully. All the questions that we are doing in the class, you must be thorough in that, and the practice test also you do. I can say that if you do this crash course itself in a good way, minimum 110 to 120 marks you should be getting. Okay, minimum 110 to 120 marks. Okay, so keep doing it. Okay, see you tomorrow. Bye bye.
Thank you, sir.
Thank you, sir.